So we've seen that the PIN structure was the simplest structure that we studied last week. It is made by a PN junction with an intrinsic junction in the middle to increase the depletion region. And light incident in the photodiode generates carriers in the intrinsic region, which are accelerated by means of the electric field in the depletion region and collected at the terminals, giving rise to a current. So basically, the PIN photodiode converts light into current. And just at the end of last class, I showed you the two possible structures. So basically, we have this PIN structure with slightly different configurations. The one on the top, the light is incident in the P junction, in the P side of the material, vertically as shown here, and the one on the bottom, the light is incident in the intrinsic region through the left as shown here. So what we're going to see now is a slightly different type of photodiode, which is called the avalanche photodiode. This avalanche photodiode has this type of structure. This specific structure is called reach-through structure, and you're going to understand in a minute why it takes this name. So as you see, it's made of a PIN structure, similar to the one we've just discussed, except there's a high resistivity P-type material close to the N side of the junction. And at low reverse voltages, the depletion region is confined to the N plus P-type region. So this region here. And within this junction between the N plus P-type region, an electric field exists in this junction. But as you increase the reverse voltage, the electric field reaches through the P plus type region, and so the depletion regions become quite large, as shown here. But the main interesting point that I want to make here is that there's a high electric field region called the avalanche region, where when an incident photon reaches the material, electron and hole pair are generated through absorption of the energy of the incident photon, as shown here. When the electron reaches the high electric field, this avalanche region, the electrons have enough energy when colliding with the atoms of the material to generate additional electrons. And so upon an incident photon, instead of just having one carrier being generated, at the end we have many electrons generated in the material. And this is known as an avalanche gain, where an electron generates additional electrons and so increases the current generated by the incident light. And so mathematically, we can express this result as if the avalanche photodiode has a multiplication factor or a gain current factor, which is defined by the multiplication current divided by the primary photocurrent when there is no gain. And so the responsivity of the photodiode, which is a characteristic of the photodiode, becomes multiplied by the gain current. And so this photodiode in particular has an advantage that it has an additional gain, and so a higher sensitivity than the simple PIN structure. This is a particular structure, a diagram of a structure of a reach through APD. And these type of photodiodes, since they have this avalanche gain, they are called avalanche photodiodes, or APD for short. The reverse voltage required in these photodiodes is quite high, can reach hundreds of volts, although the current is very small, and so the power dissipation is not that high, but still there's some disadvantages by the fact that you need to operate the device at a large reverse bias. And the device is also very much temperature dependent, because the avalanche gain depends a lot on the thermal vibration of the atoms. And so if you increase the current, if you increase the temperature, the current drops. It can drop a lot, for example. Let's see if I can draw something here. Sorry. For example, if you are operating at 300 volts, for example, like in this region here, if operating at 23 volts, you have a gain of approximately 20. Okay, but if the temperature increases to 67, then the temperature can drop by as much as 50%, and the voltage gain, the current gain, is only 10 instead of 20. So this might be a problem when working with these photodiodes that might need some temperature control as well.